like something we do in the calculator that you don't know how to do, okay, today's the day to figure out how to do it. Because next time we'll focus on the other sections of your test review. Okay. We have it mostly typed in. Okay, my mode is in radian mode. Yours should be too, not degrees. Okay, and now let's read the question as you're maybe finishing typing it in. It says, fish enter a lake at a rate modeled by E of t. So I want you to write next to the E of t, these are the fish entering the lake. So I'm going to call this my in equation. Okay, because that's the fish going into the lake. Okay, then it says fish leave the lake. Okay, and then if we could put computers away just for right now while we're doing these examples together, then you'll have time to work on whatever you need to. Fish leave the lake at a function L of t. That's my out. Now, the other thing I want to point out to you is that both of these are rates. So what that means is that you're measuring in fish per hour. So I want you to put for E and L, you're measuring in fish per hour. Now, quick question. If I take the derivative of fish per hour, what would my units go to? Fish per hour squared. Very good. Okay, if I take an antiderivative, remember typically we'll make that like go up the list. What would an antiderivative on fish per hour be? It would be just the number of fish. Okay, so to fill in the blank, fish goes to fish per hour, goes to fish per hour squared. Okay, then going in reverse, it'd be the same thing. Fish per hour would go back to fish. So look at part A. It says interpret the meaning of the integral, then evaluate. If I integrate, E of t, is that my in or my out function? E is the in or out? In, and it's measured in fish per hour, and I do an antiderivative. Now it's going to be the number of fish. Now, let's put, so this represents the number of fish. Okay, and then you just have to kind of like read the story and put that back in. So if these are my fish going in, that's the number of fish that entered the lake. So this represents the number of fish that enter the lake over, and then my endpoints are 0 to 5. So that would be 0 to 5. And then if this is fish per hour, we're measuring time in hours. So over 0 to 5. Okay, then to evaluate, you're not going to do it by hand, you're going to do it in a calculator. So let's review how to do that. Okay, you have your equations typed into your y1 and your y2, hit second quit. And then your antiderivative is math 9. You're going 0 to 5. And then if you want to put your y1 into the integral without retyping the whole equation, remember it's alpha trace. Make sure you pick y1. Okay, then because this is a number of fish, doesn't really make sense to have a decimal. So we're going to round this to 153 fish. Okay. All right. So looking at that as an example, let's now try part B. So we're still integrating. We're still going 0 to 5, but now we're doing L of t, and L of t is the out equation. So do math 9 in your calculator, 0 to 5. But now your L of t, that was your y2. Okay, versus this other one was your y1. So I want to integrate math 9, 0 to 5 on alpha trace y2. Yeah. Okay, and your value there should be about 30 fish. Okay. So I'm going to put 0 to 5, L of T is 30 fish. And now let's put what that represents. That represents the number of fish that did what? That left the lake. And then don't forget, you need to also include your units. So it's the number of fish that left the lake over 0 to 5 hours. Okay, and then when I say include units, okay, you're measuring in fish, and then your time is measured in hours. So those would be the units that we'd be talking about. Okay, next part says, well, how many fish are in the lake? Well, remember, we had 153 fish go in. We had 30 fish go out. How many fish would actually be in the lake then? What would we do with these two numbers? Subtract. Very good. So I'm going to put here the total fish is going to be 153. Those are my in fish. Minus 30. Those are my out fish. That leaves me with 123 fish total. Okay. So you have some fish going in, some fish going out. You're just going to take the out fish by subtraction. Okay, you cannot do the next part. We haven't covered that yet. Go down to part E. It says, is the overall number of fish in the lake increasing or decreasing at 5 a.m.? So you can't just look at like velocity and say, oh, it's positive or negative. In this case, the in and the out equations are separate. So what you're going to do is you're going to find out how fast the fish are coming in. That would be E of 5. Then I'm going to find out how quickly the fish are leaving the lake. That would be L of 5. And then when I know those two numbers, I'll just look at which one's bigger. If they're going out faster than they're coming in, we know overall the number of fish is dropping, versus if they're coming in faster, we know overall the number's growing. But remember, these are both already fish per hour, so I'm finding Y values. So in your calculator, find Y1 of 5, then Y2 of 5. I'll remind you of how to do that. You're going to hit alpha trace Y1, open your own parentheses, put a 5 in it, and it'll plug it in for you. Then you're going to do the same thing for alpha trace Y2 of 5. So my in rate is 27.5 fish per hour. But my out rate is 9.657 fish per hour. This is in, this is out. So overall, which of those rates is bigger, the in or the out? Which is a bigger number? In, then overall, the number of fish is going to be increasing. So we'll put over here, number of fish is increasing because E of 5 greater than L of 5. Okay, but what that means is the rate they're coming in is faster than the rate that they're leaving. So overall, you would see a build in how many fish. Okay, last little part of this is it says from 0 to 8, okay, at what time is the greatest number of fish in the lake? Greatest number of fish means that we're finding a maximum. So the first thing that I want you to do is we are going to look at a graph of this equation, but we only want to do it on the window that they've given us. So we talked about this a little bit last class, but I need you to adjust your window to be 0 to 8 for your time. So let me remind you how to do that. Push your window button, and I need it to be 0 to 8. Okay. Then go ahead and hit graph. Now, when I hit graph, I'm going to notice that really I can't see anything. Maybe I can see a little bit, but not much. Okay, so the reason why is, do you see how this, I barely caught the end of the graph? Okay, look at your Y value. Do you see how it's like 27? My window right now only goes up to 10. So now I see, oh, that's not high enough. So you're going to push the window button again, and we need our graph to be taller. So I'm going to take my Y max here, and instead of it only going up to 10, I'm going to make it like 50. Okay, this is just a guess. If you made it 75, you could probably still see the whole graph. Okay, so my X's are 0 to 8. My Y's are negative 10 to 50. Okay, and now hit graph. And hopefully now we can see the whole thing. Okay, remember, blue is my in function, because that's Y1. Red is my out function. So once you have that, sketch it on your paper. Okay. So our first function kind of did that, which is E of t. And then my out function started down here and crossed up. Okay. The place where these two graphs cross is going to be where the maximum is. Okay, let me explain to you why. The reason that this is a max, okay, go ahead and just label it, because I'm just telling you. This is the maximum number of fish. Okay, here's why. I want you to think about overall levels. We know that a max occurs when you switch from uphill to downhill, right? So increasing to decreasing, that's what a max is. Let's talk about the overall number of fish. For this half of the graph, which rate is bigger, the in or the out? In, which means overall, the number of fish is going which way, up or down? Up, because which one's bigger? The in. So overall, my number of fish is going up. And then what happens on this side? Which rate is bigger in this part of the graph? The in or the out? The out, which means overall, what starts happening to the number of fish? Now it's going down. So that means that at this point, you would have the most fish that you could get, because the overall fish numbers change from up to down. That makes that nice. Does that make sense? You should know how to find this using the intersection in your calculator. So to find that button, you're going to do second trace. And then go down to option 5 is intersect. Now, if you have multiple intersection points, you need to get close to the one that you want. But for this graph, they only cross once anyways, so we're not really worried about that. You can just push enter 3 times. So first curve enter, second curve enter, guess enter. And my intersection happens at 6.2035. We're going to round that to 6.204. Okay, so T equals 6.204. Okay, then let's put for our justify, because the overall number of fish changes from increasing to decreasing. Okay, then I'm going to add one more little detail to that, since these are like kind of notes. Okay, increasing is where my in was greater than my out. And decreasing is where my leaving was greater than my entering. Okay, so if you want to add that as a detail, you wouldn't have to put that on like the AP test. Okay, but as you're looking back, that's how we know the order that switched. Now, this is when you have the lowest number of fish. Let's say that you want to know exactly how many fish there are in the lake. Okay, then you would take your calculator, second quit, and rather than doing the integrals separately, you can just integrate them together. So hit math 9. We're going to go 0 to 6.204. And then in our little center spot, we're going to do the in rate minus the out rate. So that way, instead of me finding how many fish go in, how many fish go out, and then minusing them at the end, I'm just going to put the minus in here so they can just kind of like live in the same integral, if that makes sense. Okay. And then your number of fish at that point would be 135. 135 fish is. So this is when the minimum happens, and this is exactly how many fish that low point in the population is. Does that a little bit make sense? Okay. Let's do one more. So go ahead and turn to the next page. Okay, while you type in the Y1 and the Y2. Okay, I'll read it to you. Okay, so we're putting the first equation in for Y1, second equation in for Y2. So it says, when a certain grocery store opens, it has 50 pounds of bananas on the display table. Customers remove the bananas from the table at a rate modeled by this. Okay, where it's measured in pounds of bananas per hour. And T is the number of hours after the store opened. After the store has been open for 3 hours, employees start to add the bananas back to the table at a rate given by, and then your Y2, also pounds per hour. So once you have that typed in, I want you to label on your paper, which is the in, which is the out. Okay, so label which is the in and which is the out. Okay, for the first equation, which one is it? The in or the out, if it's the customers taking the bananas off the table. Okay, this is the out this time. And then this is the customers putting them back. So just make sure that you're kind of careful. They're not always going to make it Y1 is in, Y2 is out. In this case, it's flip-flop, but it's the same idea. These are being removed. These are being added back. So let's do our interpret the meaning of. We want to integrate F. That's our in equation. Okay, and what's going back in? Put it in like the story. Bananas, very good. So this represents the pounds of bananas. And then I think I said put back in, I meant taken away off the table. So this is the pounds of bananas taken off the table by the customers. And then in this case, it's over 0 to 5 hours. And then I'm going to add into that since the store opened. Okay. So it would be how many pounds of bananas the customers took off the tables over 0 to 5 hours after the store opened. Okay, find that in your calculator. So remember, an integral is math 9. Okay, math 9. We're going 0 to 5. Alpha trace Y1, BX. Okay, and then I'm going to put 54 as the right answer, but that's 54 what? 54 pounds. Now let's talk about units. This was pounds per hour. So if I integrate or do an antiderivative, does it make sense? I'd go back to just regular pounds. Okay, so let's write it maybe up here to the side. If it's pounds per hour, then if I take the derivative, that'd be pounds per hour squared. If I do the antiderivative, I would just go back to the number of pounds. Okay, so you should a little bit be able to make sense of those units. But if I have pounds per hour, an antiderivative undoes the per hour. Okay, go ahead and do part B. Okay, so let's write our represents first. This would be the pounds of bananas put on the table by the employees over 0 to 5 hours. Okay. Now, don't type this one into the calculator just yet. Okay, for 0 to 5 hours, I want you to look carefully at the second equation in your problem. When does it say the employees start putting the bananas back? Not till 3. And then look over here. This equation only works 3 to 12. So when I put it in my calculator, my lower limit's not going to actually be 0. Okay, this model specifies that they don't start using that equation till 3. So I'll go 3 to 5, alpha trace, make sure you pick Y2. So the customers took away 54 pounds of bananas. The employees put back 21 pounds of bananas. So go ahead and write that number down, 21.181 pounds. Remember, this one's out, this one's in. Okay, so then it says, how many bananas are on the table at 8 hours? So I want you to think about, this one has one additional thing the other one didn't. Read the very first sentence. It says, when the store opens, how many pounds of bananas were already on the table? 50. So you're going to want to take the starting amount. Then you're going to add how many were added in, the extra bananas. And then you're going to want to minus the removed bananas. Okay, but with the fish, it didn't say there's already this many fish in the lake. Okay, versus in this case, we have a starting amount that we have to consider. So in your calculator, type in 50 bananas. Okay, so we're going to do 50 plus. Okay, the bananas that are added back are going to be math 9. And then we're only going to go from 3 to 8 on Y2. And then we're going to minus math 9, 0 to 8 on Y1. So this is how many the employees add back. This is how many the customers took off. And then your starting value in front of that. Okay, so your total bananas is going to be 3 to 8 on G of T. And then 0 to 8 on F of T. And it equals 23.347. Okay. 23.347. Now, why can't I just use the 50 and the 21? What time were these answers at? 5, yeah? This was only the first 5 hours, and we're wanting the answer at 8 hours. So that's why I can't just reuse these numbers that I already have. Okay, next part says, what's happening overall to the number of bananas? Is it increasing or decreasing? Well, then I want to know how fast are the bananas going on, how fast are they going off, and then which of those is bigger. Remember, though, those are Y values, because your equation is already bananas per hour. So we're going to find F of 8, G of 8, and then we're going to see which one's bigger. So on your home screen, do alpha trace Y1, parentheses 8. alpha trace y2, parentheses 8. So I got 4124 and 13.517. Which of those numbers is bigger? 13, is that the in or the out? In, out. So if they're going back on the table faster than they're being taken off, that means overall the number of bananas is growing. Pounds of bananas is increasing. And then I'm going to put because my G of 8 is greater than my F of 8. They're going on at a faster rate than they're going. Okay, last little part of this says from 0 to 8, when is there the fewest number of bananas on the table? Sketch your graph. Okay, and then since it's still 0 to 8, hopefully we don't have to actually change it. Okay, remember the first one graphed in this case is your out, and then the second one coming in will be your in. Okay, now in this case, they're asking for the fewest number of bananas. Do they want a max or a min? Min is correct. Fewest means I want a minimum. And your minimum is still going to occur at where those cross. Let's talk about why and make sure it makes sense. The first half of this interval, which one's bigger, the in or the out? Out. That means overall, what's happening to the bananas, going up or down? Down. So put an arrow down. Okay, then at this point, that switches. Who's bigger on this interval? The in or the out? Now the in is bigger. That means that they're increasing. And so if I have a switch from down to up, that makes this my minimum. Okay, right there. You should know how to find that number. Second trace. Okay, and then we want the intersection, which is option 5. If you only have one intersection, you don't have to move closer to any specific number. You just push enter, go kind of slow because the calculators are old. Okay, so enter, enter, enter. And you should get 6.397. And then this would be measured in hours. Okay. Because at this point, amount of bananas changes from decreasing to increasing. Okay, and then just think about if that makes sense. If it's a minimum, decreasing to increasing, that's the right switch that we want. Okay. All right, the last thing you're asked to do on this question is if you have F, but you already have it in your Y1, you should know how to find F prime in the calculator. That's math 8. So get out of your graph here, second quit. Remember, math 9 is an integral, math 8 is a derivative. ddx in the first box, alpha trace y1 in the second box, and then you want the derivative at 7. So it should look like that once you have it typed in. Okay, negative 8.119 will go to 120 because it's followed by a 5. I'm going to put f prime of 7 equals negative 8.1. Now remember, f is pounds per hour, what will F prime be now that I've taken the derivative? Pounds per hour squared. And if it asks you to explain the meaning, okay, here's what you would write. Go ahead and write it and then just think about it. This means at time 7 hours, the rate bananas are removed. That's F. Is decreasing 8.120 pounds per hour each. I'll give you a second to write that down. Kind of think. So if F is how fast the bananas are going, and F prime is a negative number, then I know the rate they're being taken off the table is slowing down. It's decreasing. Okay. And then if you wanted to put pounds per hour squared instead of pounds per hour each hour, that's fine. Those are the same thing. Okay. Overall, do you get it? We could do one more. Or not. Okay. So here's what you have to work on. You have a homework that's over this. It's 2 questions, but they're broken down into parts. You also have a test review. So I love to help. If you want to do the homework now, you can. If you want to do the test review now, you can. But all of next class, we're working on the test review. Yes? So I would say if it were me, I would maybe go through one of the homework questions, make sure I know how to do the calculator stuff, and then move on to the test review. Okay? But I have to remember where. Yeah. Yeah. Okay, also y'all don't do any of the anti-derivatives. We'll do those next on the first page. We'll do those next. Yeah. And then we also will make a cheat sheet next time if you're wondering.